In this video, we're going to talk about advanced factoring of quadratic expressions. And what I mean by that is if we have a quadratic expression like so, when we look at this leading term here, the term with the x squared on it, what happens when this is not 1? Now, we've talked about videos of what happens when it is 1, and I would highly suggest if you haven't checked those out to do that first. So this will be the continuation of that process. So let's jump right into it. I'm going to start off with an example here. Let's say we have 2x squared plus 6x plus 4. Now, when we're dealing with these, there are a few different tricks we can use. This one is a little bit on the simpler side in that if you look at the 2, the 6, and the 4, each of these are divisible by 2. So we could factor out, doing reverse distributive property, a 2. So we have 2 times x squared. I'm going to divide the 6x by 2. That would give me a 3x. And then I'm going to divide the 4 by 2, which gives me a 2. Now I can look at just this expression where I have a 1x squared. And then I can use my tricks that I already know. I'm going to look at the factors of 2, which in this case, there's only 2 factors of 2, and ask myself, do they add to 3? They do. So then I can rewrite this as 2 times x plus 2 times x plus 1. And we can leave it just like so. Now that's one example, and I'm going to show you a couple others. That's one way, so I would do that first. If these coefficients and this constant have something in common from a multiplicative sense, factor that out first. It'll make your life a lot easier. Even if you don't get it to 1, if you can get it from 20 to 2, that's huge. So let's look at another one. In this case, if I look at the 13 and the 6, neither one of those are divisible by 2, or by 5. So that last trick we used isn't going to work. So I have to think to myself, okay, how can I make 5x squared with our 2 sets of parentheses here? So if I'm looking at it, I have to consider the factors of 5. In this case, since 5 is prime, there's only 5 and 1, so I know I have to have a 5x and a 1x involved somehow. So I can just go ahead and write that down. That's what's going to happen. Now, if we think about what happens when we were to FOIL this out or do double distributive property, whatever this term is here is going to be multiplied by 5x. I have to keep that in mind. And this guy is going to be multiplied by 1x. So again, I'm going to consider the factors of 6, but I have to consider them a little bit differently. So 6, thankfully there's not too many factors. There's 2 and 3 and 6 and 1. Now I get to multiply one of these by 5 because of this green line here. And then I get to add it to the other. So somehow I have to make 13 with that. So we could think about it, okay, if I multiply the 1 by 5, that makes 5 plus 6 is 11. So I know that there's not a 1 in the green space and a 6 in the yellow space. Okay, if I multiply the 6 by 5, that makes 30, and then the 1, that would make 31. So it's not going to be 6 and 1. No way, no how. Okay, so then let's think about the 2 and the 3. If I multiply the 5 by the 3, that gets me 15. The 2x would be positive, then I'd have to add it, so that would make 17x. So that one's not going to work with the 3 in the green spot. So if I put 3 in the yellow spot, though, meaning multiply the 3 by the 1x and the 2 by the 5x, that would make 10x and 3x. So I think that would work. So it'll be 5x plus 2, or no, plus 3, forgive me, and then x plus 2 is how this one would factor. And if you're not sure if it works, you can always do your double distributive property, FOIL it out, the smiley guy, whatever it is, and check it. But this is how it would factor. And it's a little more difficult because of this leading coefficient here. It changes kind of the whole dynamic of what am I doing. And this 5x multiplies one of these by 5, and it's useful when that number is prime at the very least, because then you only have one set of factors. In the next example, we'll talk about what happens when it's not prime. So this example, we're looking again, how can I make x squared happen. I'm not seeing a way I can pull a 4 out of this 7 or technically a 1 here. So I can't really divide out a 4 like I did in the first example. So there's a couple ways we can factor this. Either we have a 4x and a 1x because factors of 4 would be 4 and 1, or potentially we may be able to factor it as 2x and 2x because factors of 4 would be 2 and 2. So one of those two options is where I would go. Now I kind of have to try each of them. Now thankfully, if I look at 7, there's only 2 factors of 7, so I can try them in either spot and see what happens. So if I try the 7 in this green spot, I'll have 7x, and then I'll have 1 times 4x, that makes 11x. So the 7 can't go in the green spot. If I put it in the yellow spot, that would make 28x, and there's no way I can make it down to negative 1x. So I think we can eliminate this contingency. It's not going to factor like this. Okay. Now let's try the same thing with the 2x and the 2x. Now this one I don't really so much have to try a different way because I get to double both of them and then add them together because they're both 2x here. Well, if I double 7 and double 1, and I add them together, that would make, well, I'd have 14 and then I'd have 2, and there's no way I can make negative 1 with some subtraction there. So this is an example, now that I've run through all the possibilities, is what we would call a prime trinomial, meaning it does not factor. And we'll talk about what to do with those later. There are, if we're looking to solve an equation like this, there are tricks that do exist that we can use. However, right now we're just worried about the factoring.